Hi class, sorry I'm gone today. We are doing notes today on 6.5 day 1. We're going to be dealing with rhombuses, or plural, that's rhombi, and we're going to do squares. And at the end you're going to be given 4 coordinate points again, and you're going to have to determine whether it's a rectangle, a rhombus, or a square. So, let me see if I can get this to move down for us. When we're talking about a rhombus and a square, away. A rhombus is what I would call a slanted square. It has 4 congruent sides, and on your sheet that you have with that we've been filling in the chart with the dots on it, okay, pull that out. All right, you're going to want to fill in for a rhombus that the first dot is going to be that it has 4 congruent sides, okay, 4 congruent sides, and keep that sheet out because we will be filling that in throughout the notes today, okay? So fill in your sheet that has the quadrilaterals on the top, and we've already filled in parallelogram and rectangle. We're on rhombus now, okay, and dot number 1 is 4 congruent sides. Now, the diagonals of a rhombus, okay, are they congruent? Right? I'm pulling up these notes, and these notes will be posted online for you to see just as a PDF also. But imagine if I could work with this right now. I can't because this is a PDF. If I could pull that pink triangle up and I could pull that blue triangle up, this here would be the diagonal going along this way, and the slanted part of this blue one here would be the diagonal going the other way. I think you guys can probably look at this and tell that the length of this side here and the length of this are not going to be the same. Anytime you have a slanted figure like this, the diagonals are not going to be congruent, okay? So do not fill that in as on your dot sheet, because that is not a characteristic of a rhombus, okay? But I don't want you to think that it is, okay? However, though, because we have a parallelogram, okay, a rhombus is a parallelogram, so everything that was true about a parallelogram is still true for the rhombus. So on a parallelogram, the diagonals bisect each other. So when you look at our rhombus here, around the outside we have 4 congruent sides, so they're all marked with a single mark. And then the diagonal going this way, that's going to get cut in half, so I have the double marks. And going this way, we also cut that diagonal in half with the 3 marks there. Okay? Because of this, what happens with a rhombus is you end up with 4 little congruent triangles. Okay? So there's 4 congruent triangles. That is not your next dot on your sheet though. Okay, but that's a really important thing for you to understand. If you understand that, that concept is going to help us figure out a lot of other things that we're going to want to work with as we go through our rhombus. So, since there's 4 congruent triangles, okay, what does this prove about the corner angles and the diagonals? Okay, well, the diagonals are going to bisect the corner angles, okay? And here's why. Let me kind of scroll over to a picture here, okay? This is your picture. In a little bit, you probably want to pause this so you can fill this in on the back of the sheet where we've been filling in our rhombuses and all that kind of stuff, okay? Since you have these congruent triangles, okay? If I look where the single and double meet, I have marked all those spots with an A. And where the single and triple meet, all those spots have been marked with a B here, okay? And once you have that all filled in, you'll notice that you have A's on both sides here, and also down here, A's on both sides. And in the other corners, you have B's, okay, on both sides of the line, which means that that diagonal line is cutting that corner angle in half, okay? So say it was 120 degrees in this corner up here, then each little part would be 60. It's getting cut exactly in half, okay? So dot number 2 on the front part is going to be that the diagonals bisect the corner angles. Okay? Now, another important thing happens because of these congruent triangles. In the middle here, okay, all of these triangles have the double and triple meeting at this middle intersection here, okay? And me having it labeled already as 90 kind of ruins the surprise of figuring it out. But think about it. If you have just kind of cover up half the picture, okay, and just look at these two here, for example, okay? Those together have to make 180 degrees, but if they're the same, they're going to have to be 90 degrees, okay? So on a rhombus, in the middle here, you're always going to have 90 degrees, okay? The way that we word that for the third dot on your rhombus box is that the diagonals are perpendicular. Diagonals are perpendicular. Okay, once again, dot number 3 in the rhombus box, diagonals are perpendicular. Okay, if you need to, I would maybe pause right now and copy this onto the back of your sheet, label it as rhombus up top here, okay, and you can fill in this information here. All right, another thing I want you to fill in with that, okay, is that you also have Pythagorean's theorem. Okay, anytime you have a right triangle, remember that you can use Pythagorean's theorem to find a missing side length. If you have two sides of a right triangle, you can find the third missing side by doing Pythagorean's theorem. Remember, the C in Pythagorean's theorem has to be the part that is across from the 90 degrees. So that would be this part here. Okay, and remember, on a rhombus, all of these outside parts are going to be the same as you go through it. So maybe pause here to fill in your sheet if you need more time to still fill it in there. I guess I also have this one down here that you can use, okay, that I have filled in. Remember, with these, because you have a right triangle, okay, the spot here in the corner here, and that's what I'm trying to show you here, that the A and the B's together are going to make 90 degrees also, because you have a right triangle. 90 degrees is already used, so of the 180, the A and the B are left to make the other half, the other 90. Okay, so this is your sheet for your rhombus. Okay, here is the book, just telling you those two rules as you go through it also. Okay, and remember, I posted this as a PDF also, that if you want to just go and pull up the PDF notes to copy this down, you can also. All right, moving on, here are some problems with it. Okay, they're telling you that WZX, okay, that's this angle here, sorry, it's a little messy, that's 39.5, and they want to know this angle over here, ZYX, the whole thing in the corner here. These are not the same, remember, okay? But remember, these two on the sides of the diagonal are the same. So if I double 39.5, okay, because this spot here will also be 39.5, I get 79. So this whole corner here is 79. And remember, on any parallelogram, the whole corner angles have to add to 180 when you have the consecutive angles there. So 180 minus 79 leaves me with 101 there. And ignore that, somebody must have scribbled on that and made stars this year when I made this. Okay, here we have another problem. It's giving me the top with algebra, and it's giving me the left side here with algebra. Remember, this is a rhombus. All four sides around the outside are the same, so you can simply go 8x minus 5 equals 6x plus 3. And I didn't work it out, but just that would be the setup. You can work it out from there as you go through it. Now, this is a Venn diagram. Okay, so if you ever hear about a Venn diagram, this is a Venn diagram. A Venn diagram is where you kind of have layouts and it shows the characteristics and how sometimes they overlap. Okay, well, we have parallelograms as general. That's our big box kind of going around the outside. Inside a parallelogram, we have subcategories. One of those subcategories is the rectangles that we covered last week, where you have to have right angles in the corner. Okay, right now we just talked about rhombuses or rhombi, where they have to have four congruent sides. Where those overlap, if you have a shape that has right angles and it has four congruent sides around the outside, then it's going to be a square. Okay, from this you can look at this, and this is really just a different version of the sheet that you're filling in with the characteristics. Okay, everything that is true for a square, okay, for a square, everything that's true for a rhombus, a rectangle, and a parallelogram is going to be true for a square, because a square is inside of all of those boxes. Okay, remember how we said earlier that for rectangles, everything that was true for a parallelogram is still true. Same thing with a rhombus. Everything that's true for a parallelogram is still true for a rhombus. Well, a square takes it one step further. Everything that's true for the parallelogram and the rectangle and the rhombus is true for the square. So on your square box, on the front of your sheet, okay, just put down for the dot, it's just one dot. We're not going to relist everything. Just simply put all characteristics of rectangles, rhombuses, and parallelograms. Okay, all the characteristics of the rectangle, the rhombus, and the parallelogram. Okay, it has everything true. Okay, now because of that, okay, this is what happens with a square. You have the diagonals bisecting each other. So all of these four little parts are the same. So you end up with 4 congruent triangles. Okay, they're all going to be the same. And because the diagonals, this little corner is getting cut by the diagonals, the 90 degrees that have to be in the corner each get cut and have to be 45. Okay, and like we had with the rhombus, you're going to have 90 degrees in here in the middle. So all of these little triangles are also 90 degrees. Remember, you also have a big triangle if you just take half of a square, where you'd also have 90 degrees, where you could do Pythagorean theorem. So anywhere you have a right triangle, here you can do Pythagorean theorem, and it's always going to be 45 degrees in the corners and 90 degrees down the middle here. Okay, if you need to take a minute here, pause this so you can fill this in on the back of your sheet. Okay, I'm going to move on here now to looking at some problems with this. Okay, we have a rule here that says if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Notice it says you already have a parallelogram. So today in your homework, they're going to tell you already that it's a parallelogram. But from there, you need to figure out whether it's going to be a rectangle, a rhombus, or a square. So you already know, the top is the same as the bottom. The left is the same as the right. Those kind of things that are true for a parallelogram. If those are true and the diagonals are perpendicular, making a right angle in the middle there, then it has to be a rhombus because that was a characteristic of a rhombus. Okay. Now, could it also be a square? Yes, but in order to be a square, we have to prove that it's a rhombus and a rectangle. Okay. So for this, we're just saying right now it's a rhombus because rhombuses can be squares. Okay. A square is a special type of rhombus. Here's another rule. It says if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. Basically, it's saying if the corner angles here are cut in half and they're the same on both sides here, then it has to be a rhombus. Notice you have to know it's a parallelogram first before you can say that. Here's another rule, okay? It's saying that if the consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So we know it's a parallelogram, which means that the opposite sides are the same. So these two are the same and these two are the same. Well, if I just have two that come together and make a corner, the consecutive sides the same, well, if this one, whatever this is, the one over here is going to be the same. So if this is 7, this is also going to be 7. If these two are the same, then over here this has to be 7 also. Then over here would also have to be 7. So you don't have to have all 4 marked. As long as you know the two, that you have to know first that it's a parallelogram. And then if you know the two coming together and making a corner are the same, then all 4 of them are going to be the same and it's going to have to be a rhombus. And also, if a quadrilateral is both a rectangle and a rhombus, then it's a square. So, in this example, do we know that this has to be a rhombus? Well, we know it's a parallelogram. So whatever we have for the length here, this one would have to be the same. And AD over here, whatever that is, this one has to be the same. And since these two are the same, all 4 are going to be the same. So yes, we would know here this has to be a rhombus. I didn't write it down here, but the reason you would say would be parallelogram and consecutive sides congruent. Here's another example. We have a figure, a quadrilateral, and we know these two sides are 6. Okay? They also say here that he has it where we know, I don't know if this problem is written really well, but we're going to say it's a parallelogram, so all these sides are going to have to be 6. Okay? Because he set everything 6 feet apart, so that's why everything has to be 6. So yes, it would have to be a parallelogram. Okay? Is it going to have to be a rhombus? Well, yes, because all the sides are 6. So yes, it has to be a rhombus. Now, does it have to be a rectangle? We don't know yet. Okay? Right now, I would have to say no, it's not a rectangle. I don't know for sure. It looks like it has right angles, but it could be slanted. He could have been off when he laid them out, that he got, it's slanted like a rhombus and not with the right angles in the corner. It'd have to be a rectangle. So we need more information, and the thing that we would need to know is that the diagonals are congruent. Okay, that, or if you were on a graph, you could do the slopes being perpendicular, but in this situation, you'd want to measure the diagonals. If the diagonals were the same, then it would have to be a rectangle, which would mean in this case then that it's actually a square, because a rhombus that is also a rectangle is a square. Now, here gets to the longer problems in your homework where they give you 4 points, and you need to determine whether it is a rectangle, a rhombus, or a square. It's nice in this problem that they already tell you it's a parallelogram, so you don't have to go through the work like we did in 6.3, I believe it was, of proving that it is a parallelogram. However, though, we still need to distinguish whether it's a rhombus, a rectangle, or a square. If it is yes that it's a rhombus, but no to being a rectangle, then your answer is going to be just rhombus, okay, because it's not a rectangle. If you say just yes to a rectangle and no to a rhombus, then your answer is that it is a rectangle. However, though, if you say yes to both of them, then it's going to be a square. It's a rectangle, a rhombus, and a square. I think your book lists them as both. Here's kind of a example of this, okay? So if you do your work and you figure out that it's a rectangle, and you figure out that it's a rhombus, then your answer is going to be square. If you say yes to a rectangle and no to being a rhombus, then it's going to be a rectangle. If it's no to a rectangle and yes to a rhombus, it's a rhombus. And if you say no to them, both of them, it's just simply a parallelogram. Okay? So, well, how do you know whether it's a rhombus or a rectangle? Well, for a rhombus, you have 2 choices for proving whether or not it's a rhombus. One of them is to prove that it has consecutive congruent sides. You would have to do the distance formula 2 times in order to do that. And that's what they're doing over here in this example. They're doing the distance formula with BD and AC and showing that they are the same. Okay, BD and AC are the diagonals. Wait, hold on. Take that back. Those are the diagonals. That's what you would need to do in order to prove that it is a rectangle. That's what they're doing down here. Sorry, I thought they were doing the sides here, but they're doing the diagonals down here. So that what they're doing for their work up here is actually proving that it is a rectangle, okay, because the diagonals are congruent. Okay, you could do consecutive sides though, like AB here and BC, and if you did the distance formula with that, that would prove that it is a rhombus. Okay, I chose when I went through and do this to do the second option. I think it's easier to show that the diagonals are perpendicular. If you have it graphed out, which I want you to do, okay, so grab graph paper with the part that has, 3 graphs on it and white paper on the side so you can do your work. You can just simply count, okay, from B to D, it's up 1, 2, 3, 4, 5, and 1, 2, 3 to the left. So 5 over -3. There is a negative there. You can't see it very well, but there's a negative there. So the slope of the 1 is 5 over -3. From A over to C, I go 1, 2, 3 up, and 1, 2, 3, 4, 5 to the right. So that is 3 over 5. Notice they're reciprocals of each other. You can flip them around, and one's negative and one's positive. So that means they're making a right angle here in the middle of the shape, which proves that this has to be a rhombus. Okay? For proving that it's a rectangle, we could do like the book did over here and do the distance formula. Okay? Or you can show that the outside 2 corners that come together on the outside are making a right angle, just like we did with diagonals here. So if I count the slope of D over to A, I would go up 1 over 1, 2, 3, 4 to the right. So that's 1 over -4 or -1/4, wherever you want to write the negative with it. Okay, so AD is -1/4. Then if I check A to B here, I go up 4 over 1. So that's 4 over 1. Once again, they're reciprocals of each other and they're opposite signs. So yes, this is also going to be a rectangle. Well, if it's yes to a rectangle and yes to a rhombus, my final answer is going to be that it's going to be a square. Okay, so you have to have your work shown for proving it's a rhombus, yes or no, whether it works out. Check to see whether it's a rectangle, yes or no, about whether it works out, and then determine which one it's going to be as you go through it. Okay, so that's where you'd want to use this little table, this chart, as you go through it. Okay. Here's another example. I'm not gonna go through it with that there. I think we pretty much have covered everything we need to as we go through here. I'm just gonna check some other things here. We're not gonna pay attention to these with me being gone. Okay, so your homework for today is 6.5, day 1. Tomorrow we'll cover a little bit that's left on 6.5 and probably be doing a worksheet that it has down as a quiz there with it also, and going over any questions you have. All right, have a good day. Thanks.